So I hope everybody had a good 4th of July. Tonight's meetup speaker is Bill Doty, and he's going to be speaking on building a solid foundation, IT architecture, and information security. So if you want to go ahead and take it away, Bill.
Sorry, just had to unmute myself there. How y'all doing tonight? I don't know if you guys have been to other of the STL Cyber Meetups, but I've presented once before and I've been coming for a long time, over a year at this point. So I'm not a newbie at this. Been enjoying the meetings, and usually it's nice to get out of the house and have a drink and talk to everybody and compare notes and all of that. So hopefully someday we'll be back at the T-Rex building and enjoying ourselves in a little bit different fashion. So first of all, let me introduce myself. My name is Bill Doty. Friday I was a cybersecurity architect at Ameren. As of Monday, I am actually now a cybersecurity engineer, but the difference is somewhat minuscule, so I still report through the same team and I'll have some of the same duties. But I've been at Ameren for 18 months, a little bit over 18 months now, and as a cybersecurity architect in that team. Prior to that, I have done a little bit of everything in the IT business and had a little bit of everything done to me. I've been a sales engineer, I've worked at internet service providers, I was a network engineer in Cisco gear, I was a systems engineer. I've been paid to do almost everything except code, and I've done enough coding when I wasn't getting paid for it that at the very least I know I'm not good at it. So that's not my forte. Talking tonight is I wanted to discuss something that's near and dear to me, which is enterprise architecture and particularly security architecture and what that means. And the truth in the matter is that most people don't even know what enterprise architecture is. If you've been to college level courses in IT or cybersecurity, you've heard the term. You may have heard it bandied about with bigger companies. Smaller companies generally don't have the luxury of having positions like this in terms of budget. Pardon my dog, she's trying to be protected. She doesn't know anything. Hopefully she'll be quiet. So enterprise architecture is one of those glass boxes that kind of sits at the top of the building. And even if you're a regular IT guy at a big company, you may have an enterprise architecture group and you may never touch them or hear from them. So I wanted to kind of peel that back and talk about what it means and what it is and how it can be useful, both from a IT standard as well as a cybersecurity standard. So one thing that you might not know about me, and I'll tell you up front, I don't consider IT and cybersecurity to really be different things. My background, and there's at least one person in the audience that can attest to this, used to work for me back in the ISP days, but when I worked for an ISP, everything we did was cybersecurity. Every machine we had a public IP address, and we were responsible for maintaining that. We had customer billing data. We had, you wouldn't believe the information that people send back and forth, or perhaps you do. So I've never really seen a difference between protecting systems and securing them and my job as an IT professional. That's probably my bias from the jobs I've had, but that can give you a little insight into how I think about my world and the things that I do. So starting on the first slide, now it's, come on, there we go. Enterprise architecture, you can read the slide, but this is just a way of planning and designing things at the very highest levels. It is a way of looking at the business and then looking at the decisions that we make in information technology in order to support that business. So I'll give you a few seconds to read that. There's a lot of words there and it's all very high level. But it's actually a really important thing because you talk about enterprise architecture. At Ameren, for instance, we have a full-on enterprise architecture group. Director level leadership, I think there's 2 managers in it now. We got a whole slew of architects. And then we also have a whole department of people like myself that do the cybersecurity aspect of that. So you're talking about over 20 people that are hired just to do what's called architecture. And honestly, what does the word architecture mean? We know what it means in the real world. When you go and build a building, the architect's the really snazzy guy that draws the pretty pictures, right? But what does that mean in an enterprise and in InfoSec and IT? So actually, let me continue to talk about that. Next slide. The idea behind enterprise architecture is analyzing both what you're doing and what you want to do to be able to get the right technology in place to support your corporate business needs. So when you're talking about financials, you're going to be looking at Oracle or SAP. Once you make a commitment into one of those, you will find it's very hard to move off of. If you're talking about desktop support, are you going to support Macs? Are you going to support PCs and Windows? Are you going to support Linux? How do you support mobile devices? How do you support laptops when they're not in the organization? All of those are decisions that are made at a high level, and sometimes they're made very quickly and very casually and very, very easy, but they have a long-term impact. Once you have invested in something, you might be tied to it potentially forever. I've yet to see an enterprise organization that's actually switched from Oracle to SAP or vice versa. All they do is they sit in an endless series of upgrades to upgrade their financial backend. So it's something that we all do. And when you talk about enterprise architecture, when you're talking about small business, when you're talking about your own business, anything that you do, you're making those decisions. You just don't think of it the same way that an organization, a big organization, a Fortune 500 organization thinks of those type of decisions. At the Ameren level, when we make those decisions, we have to be very conscious that our total technology portfolio is going to work together, that we're not making decisions in one area of the business or one technology that will have some adverse unintended impact in another place. And what enterprise architecture does is they are the beginning of that funnel. They are the ones that work with the business, and we help guide the decisions to pick the right technologies and to create a roadmap that allows us to build a supportable and sustainable IT ecosystem. On the back side of that, we are also the ones who end up getting us out of old technology debt. The truth is that we get involved in systems and we don't know what's going to happen. We could have something that we think we're going to support for 3 years, 5 years, 7 years, and 20 years later, you're still buried in it. So there comes a time where you have to look at, hey, is what I'm doing the right thing, and do we need to make that big leap and cut the cord, parachute out of the plane, and say, you know, we're going to do something completely different because now's the time. And that's also an enterprise architecture decision, or a place where enterprise architecture comes into play to be able to help people make those decisions and find the right path forward. So we're not making the details about the very minor minutiae. You know, when we pick a database, we may not care whether it is a Oracle supported database or SQL or no SQL or Mongo or something out in the cloud. That may not even matter. What matters is that we've picked the right technology or the right grouping of technology, and we're positioning it in the right way and using it in the right way. The details of exactly what happens and how that gets done, the operational aspects, that's far beyond what the enterprise architecture group is doing. And I just want to circle around and just say again, even if you're a one-man IT shop, you're making these types of decisions. You may not think about it. You may be doing it based on your own personal bias. I know I do my fair share of picking things because I hate other things. We have all probably at one point or another said, I hate Microsoft and I'll never use their technology and run a Linux desktop. So it happens. It's happened to me. That was my exclusive choice for many years. So, but we all make these decisions. The question is how do we apply that, and how do we look at that in order to make the best decisions? So even if you're a small business, even if you're a one-man shop, it's worth thinking about these ideas and these concepts because it can help you come to a better decision. All right, so cybersecurity architecture. This is a little more arcane, and again, this is what I've been doing for a year and a half now. cybersecurity architecture, what we are tasked with doing, at least within my position, and I don't think this is unusual, we take and analyze in a little bit deeper detail the security implications of any technology that's being brought forward to us. So enterprise architecture works with the business units and they say, hey, we want to build a cloud implementation of product XYZ. We do the deep dive and say, okay, you're bringing forward this product, this technology, you want to bring AWS into the picture and do stuff in the cloud. Let's look at what that means and what you need to do in order to make sure that's safe. So we're providing that first pass analysis of what are the guardrails that you need to operate inside and what is that technology actually doing. And that way we can provide some advanced warning and advanced analysis about whether or not security is going to be applied properly there. Are you making the right choice based on cybersecurity? I think anybody that's at this meeting today is going to be well versed with the idea that cybersecurity is really important. It has to be. So these are really important decisions. When any organization, for instance, goes out and looks at cloud, oh, we have all these servers in our data center and we can save all this money by pushing it out to Amazon or to Microsoft or to Oracle or to Google. That has implications. And can it be done? Sure, you can absolutely do it, but you need to consider what that means and what little things do you need to take into account. That doesn't mean that in my job as a cybersecurity architect, I'm making the detailed decisions. I'm making the big decisions. What we're saying to a group or to a particular business unit is you need to do X, Y, and Z in order to make sure this is secure. So examples of that, are we using encryption both on the wire and on the computers? Are we encrypting the databases? Are firewalls being deployed properly? Are we using antivirus software properly? All of those tools and functions of cybersecurity, we take those and we apply it and we say, okay, if you want this to be secure, here's the controls that need to be applied to your architecture in order for it to actually be secure. And there may be cases where that can't happen. The business has to operate. So if some things can't be done, vendors often have deficiencies. We all know this, right? They do something that's just outlandishly silly and doesn't have the right cybersecurity controls on it. We've all run into that. It may be the case, but at least we're aware of it. We can look for mitigating controls. We can apply other controls, or we can just audit it to make sure that if something bad happens, we know that it happened and we can take care of it. So that's what the cybersecurity architecture piece of this is. This is just a little bit of examples of different architectural frameworks. There are standard frameworks available. There are many of them. This is just a smattering of ones that are available in the real world. That this is a framework for building an enterprise architecture practice. And there are also frameworks for building cybersecurity architecture. I'm going to pick on Togaf. Togaf is the open group architectural framework. That is the world's most commonly deployed architectural framework. It is basically just a way of saying, okay, here are the pieces and here's how I apply them. It's that simple. DODAF is the Department of Defense version of Togaf. Zachman is a more business-oriented version of architectural framework. And NIST is actually the granddaddy. I'm sure you've heard of NIST and NIST standards and all that. They run our lives in cybersecurity, the NIST 800 special publications, but the NIST framework was actually the first one, and you can see an example of how that works. So it goes from the architectural side to an information architecture, to the information systems architecture. Data architecture and systems architecture are two different things. And then down to the actual delivery, the hardware and software that picks it. So you go from the business to something that's actually deployed. And that's a pretty common framework for architectural frameworks. So you start with the business need and you work your way down to how do I actually implement that. Enterprise architecture, cybersecurity architecture generally sits in front of that. So we stop stupid decisions from getting made before somebody goes and invests a bunch of money into it. We do that early analysis and we make sure it fits into the overall portfolio. Do want to call out SABSA here. SABSA is the Sherwood Applied Business Security Architecture. It is a standard that is not well known in the United States. In Europe, if you want to call yourself a cybersecurity architect, you must be SABSA certified under the European Union standards. That's their gold standard for cybersecurity architecture. The thing about SABSA that I like is that, and we've done a little bit of analysis, we've never fully implemented it in my job, but we've looked at it and we've used the nomenclatures and things, but it takes a business need. I need to transfer data from point A to point B. And then we apply what is actually being needed in order to do that safely. So you need encryption, you need user accounts, you need all of these pieces, you need a server. We take those controls, we apply that, and then we can basically just keep squeezing that down in the funnel until you come up with a secure FTP server that encrypts the file before it sends the file over a secure pipe, and then decrypts the file at the other end. So that's just a very simplified example of how you get from architecture and the business need down to an actual system that does something in the real world. I just wanted to say, if you feel the need to interrupt or ask questions, do not feel like I'm talking over you. I know this forum's a little weird and I'm used to having the interactivity when I give speeches. So when I talk to people and when I get in front of business people, so feel free to raise your hand, put something in chat, or to just shout out on the mic. I'll mute you all if you get too unruly. So moving it on. So just why do we do this? And I'm kind of reinforcing what I already said, but architecture is that high level view. That is the 50 to 20,000 foot view of what you are doing with your information technology. That's the big pieces and the really strategic stuff. And it takes a viewpoint that is looking not just over today or this project or this implementation, but also takes into account 15 years in the past and where do we want to be in 5 years in the future. So this is a way of not just looking at your immediate needs, but taking that holistic view of what you do. This is how you derive your strategy. Reducing complexity. I can't tell you how many times in my job I've seen people propose something that we already have implemented and have had implemented for years. Everybody thinks they need to reinvent the wheel. Everybody thinks that they know what they're doing, that what they have is absolutely the one true ring that will rule them all. There will always be the person that puts that out there. So we want to reduce complexity. If you have the ability to not bring in a new operating system or new hardware or a new vendor, you can leverage your existing investments. That is a really good thing. If I have to support, 3 OSs versus 20, that is much, much simpler and reduces risk, reduces complexity, it increases your security by reducing your footprint. So reducing complexity is important. Reducing cost. By having enterprise architects look at this, they can say, hey, we might be doing this over here, but we can kind of take that same thing and do something similar in another group over here. I had a project last year where one of our not a project manager, but a program director actually was looking at implementing it was basically an application, and he started building the project to do this, and somebody else went to him and said, hey, we actually did the exact same thing. The logic that we created for an application that is completely different has already been implemented and already exists within our organization. So they did not have to go back out and recode their entire application. They were able to take all of the programming logic and much of the object-oriented programming that was done in a previous project, pick it up, put it in a dev environment, and get running with a new system. So reducing costs is huge there, where you don't reinvent the wheel. You're not doing the same thing over and over again. You're getting people to cooperate by using the same technology to drive the same thing. Standardization. Again, if you work in a business of any sort, I've had this happen in small businesses, I've had it happen in large businesses. Somebody has, oh, this is really cool widget is going to solve all my problems. And it will solve all of his problems, but it's a new widget to the company. And by the way, we've got a different widget over here that solves 80% of your problems. We need to standardize. You cannot just accept that every new operating system, every new toy, every new piece of hardware can be dropped into your network. Eventually, that becomes unsupportable. So this is a really good place to enforce standards on your end user population, on your business units, on those rogue VPs that have a credit card and think that they can just go out and buy their own Amazon instance. True story, many organizations. This actually increases your flexibility, because now when you analyze something and you say, hey, this is a unique snowflake, this is the new piece out there, we need to be different. We need to look at this in terms of a 18-month or a 36-month cycle and say, hey, we're going to improve. So this is also the place where it's not just the naysayers, it's not just the people that say, no, you can't do that, which is often what cyber becomes in an organization, but it's a way of saying, hey, we understand that you do need to do this, and we're going to help you find the best way to do it. May not be the way you thought you were going to, may not be the way we thought we were going to. And in all honesty, that flexibility, I've been in situations where I've had to say, you are correct. You need a unique solution for what you're doing. It happens, and if we've analyzed it, and if we understand it, that's okay. We're not just willy-nilly checkboxing and bringing everything in. Change analysis and adaptability. So again, if you don't know what you have, this is the truism of ITIL and information technology. If you don't know what your assets are, if you do not know what you have, you are not able to analyze it or run it or make sure that it's working properly. So this is another place where we can start looking at stuff that's funneling into the organization, the projects, the programs, the applications, systems, servers, operating systems, and we can make sure that we look at it in a holistic way. So we can adapt for the future. So we can say, hey, we see the writing on the wall. Things are going to change, and we need to be ready to do that. That's also, again, where we start to flip that switch with the businesses and say, okay, we're doing it this way today, but just beware, in 18 months, we know this is coming and these changes are going to happen. So when you write your code, when you pick these products, you need to make sure that you can account for that strategic plan of, we're not going to be doing the same thing in X number of months. We deliver that message all the time, and that gives my users, the people that I work with, that gives them the ability to be prepared to adapt, and it keeps the company a lot fresher and a lot smoother. And I'm sure at this point you can see how all of this drives security. When we reduce complexity, when we standardize, when we have change analysis, we know what we have. We know what's coming in. We know what's there. We know what we're putting in, and we know where we're going in the future. And this is one of the best ways to be able to secure your organization. Again, big, small, does not matter. There is the need to be able to deliver that, and this is the place to start. I will put it another way. Is it easier to get a system put in place from day one before it goes into production with security, or is it easier to secure it after the fact when you're not even quite sure what they did? Nobody should be raising their hands on the latter. If we build security into it in the very forefront, if we have the guardrails in place, if we make those changes and adjustments, if we get the end users to buy into what they need to do, security will be baked into the whole project from the day one. If you do not do this, they will do whatever they want. They will whip out those credit cards. They will work around you, and you will end up with something that at the end of the day, you're going to have to go back and you're going to have to bolt everything onto it to make it secure. And your headache increases, their headaches increase, and nobody is happy with the Frankenstein monster hanging around in the back of the room over the next 5 years. All right. I kind of just covered this, but I'll go over it again a little bit in detail. First of all, I now work with groups all the way to the left. This year is the first time in my job where I was assigned to a particular department and I began designing projects and programs with them before they even had the first meeting. I'm doing a program right now. It's actually an application that we're designing within Ameren. And I was the very first person to stand up at the very first project meeting and got to deliver a nice little spiel about cybersecurity and the high-level guardrails that they were expected to operate within. I was part of every project meeting, every design meeting, and helped drive the eventual solution, which, by the way, was not the solution that they started off with. We completely went a right angle on it, but now they've built and are building. It's a long-term project. It will take about a year to finish, and we started in January. But we shifted completely left. There's not going to be anything that's not addressed, and the developers building this will know what they need to do before they put a line of code to paper or to development environment at any rate. So shifting left is huge. Make the expectations clear. That brings integrating security. If you're as part of the inception, then you can integrate it. You can say, this is what we need to do. It also allows you to create those standards and patterns. And I probably not everybody, if you're not a developer, you probably haven't heard the term pattern. I have some dubious views personally if I editorialize on whether patterns are a good thing or not. They can be, but a pattern is just a way of saying, okay, in this situation, here's the basic steps we follow. If you're a developer, you might develop something in Java. You might develop something in, who knows, whatever framework. You might develop it in C++. You might develop it in Python. However, there are certain things that we do in development. If we repeat those, we do them the same way. There's good best practices for doing certain things. The language is irrelevant. We still do those things. And this is the same thing with cybersecurity patterns. When we're doing authentication and we're going to use directory services, we do it the same way every time. We try to avoid doing anything that customizes authentication because that creates complexity. So those are the kinds of patterns and standards that you can apply, and you can create those. So now, next time developer comes to you, you can hand them all the cybersecurity patterns and standards and say, oh, you're using Java? Here's what we expect from you. So this is repeatable. You can make this easy for yourself in the long run. I am a huge believer in KISS. Keep it simple, and I'll leave the last word to you. There are several endings to that. You want to keep it as simple as possible. Anything gets too complex, it's not supportable, and it will absolutely drive you nuts trying to figure it out. And remember, you may not be the person that finishes this. There are projects, there are changes, you may find another job, or the guy you're working with may find another job. If you have something that's too complex, you'll end up with that indispensable guy who becomes a contractor and bills you 10 times as much to fix it and keep it running. So this is your chance to minimize that. And again, with standards, patterns, make it simple. We talk a lot about governance and regulatory stuff. So governance and risk compliance. This is where you can identify. Again, there are vendors and there are things that everybody does that have risks. We know there are problems with this system. The vendor says they're going to fix it by next year. We've heard that story a million times. So this is where, if you're part of this process, you can say, okay, we've identified, you're using this vendor, they have a known problem that they're not doing single sign-on properly. Then you can track that risk. You can put it in your risk register. You know it's something to look for. You know it's something that you can audit on inside the systems to make sure that they stay secure. If you can't actually patch something, if you can't make it go away, if you cannot compensate for it, your only alternative is to do the audit and the compliance and make sure that if it happens, you stop it immediately. So this is where you do it. You do it at the beginning, not at the end. This is also a chance to evangelize. I've said this before, I said this the last time I spoke, but we are there to serve the business. As cybersecurity professionals, your paycheck is probably not written by a cybersecurity company. not ultimately. You may work for a cybersecurity company, but ultimately they're paid by clients who have a different name on that check. We are a function of business, not a function of cybersecurity in and of itself. I alluded to Department of No, but this is the chance to work with people to solve problems in a way that everybody can live with. There are no perfect solutions, but you can minimize the hassle. Are there times where we have to put our foot down and say, no, absolutely not. You're not going to do that over your dead body. Oh, I'm sorry, I meant my dead body. This is where we go out and we can proselytize and we can make friends and we can get everybody on board with what we're doing. So this is the chance to consult, is at the beginning. And as everything else here pointed out, we bolted on security for far too long in the IT industry. That's been our standard practice. From the very first firewall back in the 1980s, security is a bolt-on. This is our chance to start doing it right. As we change things, as we integrate things, as we build things, we put security at the center instead of just putting it around the outside and hoping that the wall was bigger. So this is why enterprise architecture is so important to the cybersecurity industry and to people that are doing cybersecurity. We are trying to make it a part of everyday life, not just something that they come to us after the bad thing happens. All right, I'll pause for a second. Anybody got any questions, any comments, anything, or should I keep going? I know I tend to steamroll. I'll take your silence as acquiescence. All right, so let's talk about some actual real examples of cybersecurity architecture. This is an early draft that one of the guys in my department did. There is literally nothing here that is particularly secret. This is just a way of saying, here's how we're going to build our network. And you'll notice there's no vendors in here. There's no specific ideas down to the technology. This is the high level of, by the way, we have a cloud, we have the internet, and then we have a bunch of stuff that we have connected to that. How are we going to connect it? So this is just a very high level, and by the way, this is a conceptual model. It has nothing to do with reality. It will tell you nothing about what Ameren does or does not do today. This is just a concept to say, if we did things this way, here are the advantages and here's how we can set things up to make our network as secure as possible. You'll notice there's a lot of firewalls there. There's a lot of other devices that provide security, intrusion detection and prevention, web application firewalls for the application side of things, VPNs to connect users. All of those parts are delineated here, but I don't care at an architectural level of who is providing those services. At the architectural level, I know the technologists, the guys doing the firewall implementations are probably, throwing their hanky up in the air and sighing and passing out right now. But at the end of the day, the technology is irrelevant. The architecture is, as a first level cut of what we do and do not allow, this is what's important. And what this describes ultimately is how we allow things to connect into our network. Raise your hand if you allow anything in the network to directly connect to anything, or I'm sorry, anything from the internet to directly connect into your network, your core network, not your DMZ where the firewall sits, but I'll bet you still don't have a direct connection without something in between. I don't think anybody's going to have their hand up. Even if you've got Amazon Web Services, even if you're in a co-location, there's still going to be intrusion detection. There's still going to be a firewall. It may not be blocking things, but at very least it's going to give you that audit. So we don't allow things to just randomly connect to other things. And this is a way of describing a layer of connections. So this is how you burrow into the network. You come from the internet, and then you can connect to our perimeter, our DMZ. And then you can, if you're a VPN or a LAN user in the untrusted corporate network, you're also sitting out there. And then there's more firewalls, and there's WAFs, and there's IDPS, and there's other devices out there. And then there's another layer that is protected even more. And then, by the way, there's even more layers when we get into our very core data systems, our databases and things like that. So this is purely just a high-level view, and this is a way for us to express to the business, this is what you need to do. If I look at this document and I have a business user and he comes to me and he says, I need people from the internet to connect to my database, I can use this document to describe to him the steps and the hoops that he's going to need to jump through in order to accomplish that. Not talking about technologies, not specifics, just the big picture. So this is just an example of the network. I put this slide out of place. I knew there was another one in there. Oh, well, I'm going to jump through that. If anybody wants to come back to SABSA, if not, you can review this on your own. I think time-wise, we're probably a little bit behind anyway, but this was a view of SABSA that I completely screwed up. All right, now here's where I get personal. This is a couple of years ago, Microsoft, this is when Azure first started becoming a thing. Microsoft said, hey, how do we describe the architecture of our various disparate systems and make that make sense from an architectural level and how we build our systems? At the time, if you think about it, you have clients, Windows 10, Windows 7, older versions of Windows. We've all got one, I'm sure. We've got servers. We've got the cloud infrastructure, which is never just one thing. Inside stuff talks to the cloud talks to the inside. So you have a hybrid cloud, and then you have pure cloud systems. You also have software as a service. People use O365. You're using Google, the Google suite to do your spreadsheets and your work. So we have all of these pieces. So this was Microsoft's, and this is publicly available. I think I've got the link at the end of the thing. You can certainly search this. It will be the first thing that comes up if you search the term. And there's a lot going on here. I could spend an hour doing this diagram, so I'm not going to spend a huge amount of time on it. But what you take out of this is here are the controls and the systems that are applicable within a particular network zone or a particular set of systems. Clients have their own type of security. The cloud has its own type of security. These are the controls, these are the pieces that make a good network, or I'm sorry, a good cybersecurity reference architecture. I met a couple of years ago, right after I came to Ameren, through another organization, another group, security group in St. Louis. I became exposed to a guy in, he's actually from Toronto, and he is the chief, no, I don't think there's chief. He's the, I don't know, senior something exalted security architect for TELUS. And TELUS is our Verizon or AT&T on the mobile side. They are the largest telephone provider in Canada. And Adrian saw this document and he got to thinking, how can I make this apply to what I'm doing? And so Adrian Grigoroff, I left his name in there because he is a really nice guy. I consider him a friend now. I've talked to him a lot. He put this out there, and darn it, there's an error in this, but I will talk through that. I must have saved the wrong, oh, I have the wrong version saved on my laptop. That's the issue. He took that document from Microsoft, and if you compare the two, you'll see the similarities. And what he did is he took the internal document that Microsoft did, and he modified that to make it look more like what he was doing with his enterprise. And I'm going to start with the upper right corner. You have some sort of information security office. Every organization does. Many times that's one guy in a corner who's told, oh, there's a problem with security, you need to fix it. However, that is your information security office. There are people in every organization that do those functions that are outside of actual typing at a computer. Asset management. Somebody theoretically knows that what assets you have. Your vulnerability management, somebody probably is looking at, oh, I need to patch Windows because there's a severe zero-day vulnerability, better take care of that. So the functions up in that right-hand side are, or I'm sorry, the upper left-hand side are the Information Security Office. These are functions. They're not really controls. They're actual processes and programs that are put in place at big organizations in order to handle security. Right next to that, most places of any size use some sort of outsourcing. So your managed system security providers, those are a dime a dozen these days. No offense to our hosts, but there are a lot of them out there that provide all different kinds of security services. So documenting those as a separate thing to say, here are the things that I'm outsourcing is important. On the left side, your clients. You have a list of clients. In the center, you have each of your different security zones. And I'll define security zone now as any place on your network that has a different level of security from any other. So, for instance, you should have a firewall, and the internet is a different security zone from your DMZ. You should have at very least a second firewall interface, if not a whole different firewall. And that is going to be your private network. You might have something that's even further firewall, like Ameren does, that protects your critical data and systems. So each of those is a security zone. I would offer that clients, your Windows 10 or your Macs or your Linux client, are a different set of security zones. They might exist in the same network, but they have different security requirements considering somebody logs into them. Adrian put on-premise, so he was talking about an extranet DMZ, you have a firewall, you might have IPS, etc. The servers, and then the LAN-WAN architecture that supports that. He kind of divided it up that way. I don't disagree with that. It just wasn't good enough for what I wanted to do, and I spent about 6 months really hacking this document apart. So, and then in each of these little boxes, when you do the box on premises and extranet DMZ, that's just a list of controls that allow you to operate and to say, I've got these controls available. Or more specifically, these controls are the ones that are required. If you want to do something in the extranet DMZ, it needs to be behind a firewall. If you're putting something in a public cloud, in AWS or Azure, you need one of their firewall services in front of it. So this is just at the highest level saying, here are the controls and here's what we do with them. The other really cool, the bottom is just services that should write across everything. For instance, you're going to need identity and access management. You're going to have to authenticate your users. That's a really critical service, and that ought to span everything you do. So the ones at the bottom are ones that are across all of these and span all of these different network zones. Now, on the right, that is, if any of you are familiar with NIST's CSF critical security or cybersecurity cybersecurity framework, NIST CSF. This is basically, Adrian just took down he broke down the 5 realms of the NIST CSF, and he just put the different controls into each of these that would apply within that particular grouping. So the one last thing, and this is one of the coolest things that Adrian did with this document, I've been in awe that he thought of this when he did it. The color coding of each of these controls represents where it's at. So you can use this as an architect to say, okay, we don't have something in place today, but we need to have it in place by 2021. So you can actually represent both projects in flight, and you can represent gaps into this document. Now, besides doing a complete revamp of this for my purposes, the other thing that I added oh wait, here it is. I forgot that I had this. Okay, so this is closer to my version of this. I took Adrian's document, and my final result actually spans about 9 pages of 8.5 by 11 paper if you were to print it out.
I've done so once. I made a few changes, and what I did was I broke it into a more manageable chunks for what we were doing within our network. This is a really early cut, and again, there's nothing on here that's going to tell you anything really useful about Amarin other than we're not idiots. Perhaps the biggest thing that I did do, however, is I added governance to this document. So we have governance functions. Everybody does. Whether it's personal data for, if your business manager takes resumes and has them in PDF files on her computer, congratulations, you are now responsible for people's social security numbers. If you're a bigger company, you've got a lot more to worry about. SOX data for SOX audits if you're publicly traded. In my case, we happen to belong to the energy industry, which means we're guided by a whole bunch of regulations we have a nuclear plant. There's a separate organization, the Nuclear Regulatory Commission, that tells us what to do with our IT systems out there. We have NERC-CIP that governs our energy centers. This is where the non-nuclear power generation. We've got a whole bunch of them. We do natural gas, we do coal, we do wind, we do solar. So we have a whole bunch of regulations there. We have personal information for our employees. We do insurance. By the way, that's regulated, that goes into HIPAA. So what I did was I said, okay, if you take the yellow lines or the yellow boxes in this, we can represent within a specific zone, we can represent what data is hosted there or allowed to be hosted there. So it gives us another view of where the regulatory stuff should be. If you're in a NERC-CIP zone in your operational technology, then that's the only place that it's acceptable to put NERC-CIP regulated data. I tried to make this generic a little bit. So again, my full document is a lot bigger than this, and we represent, here's where we store our PII. Here's where we put other things. And again, everybody's got it. We're not unique in this. And here's what this document was designed to do. I started working on this right after I came to the company, before I got assigned a whole bunch of actual work that was part of my job description, just because I was trying to figure things out, and I started talking to people. And so I started identifying the technologies we had and the controls that we wanted from those technologies. And, here's our antivirus vendor, and this is what and this is what we need from our antivirus software, just a very high level example. Then I started breaking it into different layers that really there's a public layer. There's a layer that encompasses our demilitarized zone of our network, and it encompasses Office 365, which we utilize. And it encompasses AWS, and it encompasses Azure. And it also encompasses all those softwares as a service that we happen to have for various and sundry purposes. But below that, we have our core network. We have our data center and our corporate network where all of our users live. And beyond that, we've got our energy network. So I broke it into 3 layers going down, which is why the document got so big, but it allowed me to granularize where the controls were and where they needed to be. The other thing that this did is because Adrian and I both used the way of breaking it into different areas, operational technology, data center, DMZ, whatever it may be, it also allows us to split those off into their own documents and make those, whoever's running our data center, this is your problem. But we can also use that to map to the actual programs. We can say, okay, here's antivirus. Antivirus, by the way, right now we're using Symantec. We might use McAfee next year. We might use something else after that. Who knows? Don't know what the contract's going to look like. Don't know what the capabilities will be. But for the people that care about the controls versus what the actual technology is, we can create technology lists that back this up going further down that food chain. So that was my way of linking the theoretical cybersecurity architecture piece back to what people were actually doing. Okay, so I've alluded to this, but I really want to drive this home, that everybody makes these types of decisions. If I've been the sole IT guy at small companies, And I've also been the IT guy who's basically running a technology company. We all make those decisions. I can tell you, I'll give the best example I have. When I ran 3 different ISPs in the St. Louis region for over the Y2K timeframe. Do you really think that my technical staff had any Windows machines other than what was absolutely forced on us by corporate? No. The top tech guys, we all had our Linux workstations. We had them firewalled. We built our own kernels. We made those architectural decisions because of our personal biases and also because Windows 95 sucked. Did I say that out loud? I'm sorry. Windows 98 was worse. We all know that. But we make these decisions either consciously or unconsciously, and sometimes we don't think through it. We make it based on bias. We may make it based on experience. I'll give you another really good example, and I have seen this be true at every big company I have ever worked with or worked for. The firewall guys never will change what firewall they use. If they use Cisco, they will make every attempt in the world to live and die and go down using Cisco. If they're using something else, they will continue to do that. Making people change out of their ruts, out of their bias is very difficult. People don't analyze it. We have that unconscious bias that allows us to, that kind of keeps us in that technical rut of familiarity and comfort. If we actually write it down and start thinking about it before we do things, we can break out of those. There sometimes, every once in a blue moon, there are better solutions. Just because we didn't do it that way doesn't mean that we shouldn't think about doing it that way. You know, this is the grandparent problem. Well, in my day, I used to use Cisco ASAs on everything, and I never had a, that's the grandpa thinking right there. So that's what we're trying to do here is to take that big picture view so we can analyze what we're doing and why and look at the choices. We're not wrapping it into a specific vendor or a specific technology. Then again, this leads to better integration. If we analyze what we're doing in this day and age, as we move into a world where everything is going into the cloud and where we don't necessarily even know where our stuff is, and I say that in the most literal sense, that back in the day when I ran a data center for an ISP, I could point to the hard drive that held my users' data, and I could say, all my emails and my email server are sitting inside this box in this disk array. True story. Where's your email when it's at Google or in O365? It could be anywhere, literally. Probably in the United States if you're in the United States, but literally it could be anywhere. So we need to think about how we integrate. If you're integrating cloud applications, if you're working in that area of information technology, and I realize I'm running up on the limits here. I will get done soon. We need to look at how we integrate applications. If we have developers building applications, how did they get to the data? How do we build a proper 3-tier architecture of web server, application server, database server to protect our information? That's all early analysis stuff. And if you let your developer make that decision on the fly, they'll do it the simplest possible way. There's a million horror stories on the web. That is a reduction of technical debt. If we get rid of complexity, if we get rid of extra operating systems, if we get rid of 4 different kinds of databases and take it down to 2, that makes it easier to support. We're not costing the company as much money to do their job or to run their business. And that's how we look at the future. Again, this is the keyhole that we can hold our eye to the door and say, what's coming down the road? What are we going to see 3 or 4 years from now? In this, here's links to all of the organizations and things. Managed Sentinel, I did not mention that, but that is Adrian's original publication, which he still maintains. And by the way, you can grab his document in pretty much any format you desire. He's done some stuff with slicing it into PowerPoint for executive presentations. I've done similar stuff as well. So Adrian's article there on that, and he's on LinkedIn as well. He's a nice guy. At very least, you should follow him. His passion is Azure, but he talks cybersecurity architecture all the time. And then this is who I am, and you're more than welcome to send me queries or friendly notes or curse at me for talking too much. You know, it's I always enjoy doing this. So I want to say questions, comments, anybody got anything? Wow. Not a single one. Really, guys? Come on. Nobody? Well, then let me turn it back over to Elizabeth for closing remarks. And if you want to have any questions offline, there's my email. You can get a hold of me on LinkedIn. Sure, you can find me.
Question, Bill.
Yeah, sure, absolutely.
It's kind of it's a little off topic. I just got into cyber. I've been in this for like 3 years. I'm a cybersecurity student at Forest Park. I also just completed a full stack web development boot camp. But one area I'm lacking is like email and I mean, I do know a little bit about it, but I do know it it goes down the wire and clear text. I mean, I guess unless you encrypt it or whatever. But do you have any recommendations? Because I use a lot of my accounts are Gmail, but I'm trying to get off Gmail and get into something maybe more secure. Do you have any suggestions with like with emails and stuff like that?
To be honest, I don't. I will be very frank in that I tend to be a Luddite. I'm not a huge technology user behind the scenes. I use my computer to web browse and look at news sites and read the bad news. However, there are several, and I cannot put my name around them right now. There are several free and low-paying alternatives that offer completely secure, automatically encrypted email type services on the web. If you're looking at that, if you're looking to learn about it, the subject of email is a massively complex one that, you know, it's well worth digging into, but it is an art and science all of its own. So I would start with a company called Proofpoint. They're one of the biggest email services for corporations, and they have a ton of white papers and information on email and good and bad practices and services like DKIM and securing email and things like that. So I wish I had a better answer for you, but this is one of those places where I just don't care and generally don't do anything in that area.
Yeah, thanks. Yeah, I've been kind of putting it off, but I need to kind of dive into and start studying email. I mean, for right now, I just kind of try to separate all my emails and I kind of try to ghost them out as much as possible. But like, I'll separate them from like my business and emails to like my personal. A lot of them I'm kind of afraid, like if you use Proton, for example, that's headquartered out of I think Switzerland. So basically the EU or Switzerland can basically just pull up all your even though they say, yeah, trust us, you know, I'll be secure, they can basically pull them all the information out there. So I don't know.
Well, and you also have to think that, hey, they're in Switzerland, which means that the NSA has less access to them. So there's good and bad, right? You know, the little guys in black hats in America, I'm not sure that everybody in this room would agree that they are less dangerous than the European Union. So
yeah, that's a good point too. Yeah.
You know, I would say, honestly, one of the things that is probably the best strategy for identity on the internet is to divide it up as much as possible. Keep throwaway accounts and don't use anything for commercial purposes that you're going to use for professional or for personal. Don't buy, you know, if you can manage it, and there are programs and there are services that will provide this, basically throwaway email accounts. You can place an order with an email one time and basically it's gone, so that all of the tracking for that goes bye-bye. I would highly recommend divide stuff up as much as you can, unless you've just made the decision to white flag surrender and realize that it's useless. I will tell you that email is the absolute worst, both as the person who was literally the email admin security guy for, again, 3 different ISPs. People are idiots. You would not believe what they put in them. You would not believe what they send. And it is not secure at all unless you are encrypting it. If you're not using MIME or PGP or something else on the back end, you are screwed. If you don't know that, you need to learn it real quickly. So it's a very good lesson to
to take in and to start looking at.
Yeah, right on.
Thank
Thanks,
you
man.
so much.
Oh, you're welcome. Anybody else got any questions or anything? I'm not necessarily limited to just what I talked about tonight. If you need any tips or pointers, I know a lot of the people in this group are ones that are starting their career, and part of why I do this is to give a little bit of perspective and help to get them started off.
All right, if nobody has anything else, thank you very much, Bill. It's always a pleasure having you speak for us, and I do hope that you'll want to speak again at some point.
Oh, the problem's usually getting me to shut up, but I really do appreciate doing this, and I appreciate the opportunity, and I have a lot of fun doing this. So thank you for asking me.
No problem. Hopefully we'll be able to get back into the T-Rex again. It's really all just dependent on their rules. Currently, they're open, but they're limited to 10 people per room. So we'll just have to see how things go with COVID situation and all that. But really looking forward to having everybody in person again. And we will still try to do some sort of recording just so that people who can't make it in person will not be left out. So definitely going to keep those things in mind. And yeah, once again, great presentation as always. If nobody has more discussion, I guess have a good evening, and thank you all for joining. I'll be posting the notes tomorrow along with the recording of this video in case there's anything that you guys wanted to recap. So thank you very much.
Thanks everyone for coming tonight. I really appreciate it. Have a good one.
Thanks, everyone. See you.
Thanks, Bill.